It's always been about the constant process of learning and understanding. The electrical grid is something, honestly, that has not had any change for almost 50 years. The last time there was a major change in the electrical grid was when nuclear power came on
Mhm.
in the 70s. But since then, we've had almost 50 years of almost no changes. And really, only in the last 5 to 10 years are we things like electric vehicles, photovoltaic, wind, a lot of these things that have really been changed here. And it's an industry that, if you think about it, almost no other industry spent 50 years without any change. So
Mhm.
they are having struggles adapting to those changes.
Podcast WSB-NLU po godzinach. Maksymilian Motyka. Witam serdecznie w kolejnym odcinku naszego podcastu, naszej rozmowy. I dzisiaj będziemy rozmawiać o takim dosyć ciekawym temacie, który w zasadzie kształtuje naszą rzeczywistość, a w zasadzie będziemy rozmawiać o tym, co jest pomiędzy tym tematem, ponieważ będzie dzisiaj trochę o energii, o ekologii. Trochę się słyszy o tym wszystkim, że istnieją zmiany klimatu i tym wszystkim, ale porozmawiamy sobie o takich rzeczach, które pomagają nam trochę odnaleźć się w tej nowej rzeczywistości. Taką mam przynajmniej nadzieję. A okazja jest szczególna, bo mamy specjalnego gościa w naszym studiu. Dzisiaj naszym gościem jest Robert Peterson. Good morning. Hello.
Good morning.
And I've had a bit of a trouble to how to affiliate you on this podcast, so I would just hand you the opportunity to describe yourself,
Sure.
if you can.
Sure. I'm a chemical engineer for my undergraduate degree, and I've also have a graduate degree in management of technology, and that is how do you take technology and get it adopted into the everyday use. And I've been traveling around the world, seeing how all different countries have similar issues, but how we go about them is the goal is usually the same. So I've really been heavily involved in the electrification of the grid and how we best go about that.
Okay, and and as I've read on your program, you've worked on the intersection of technology, energy, human behavior. How would you describe what drives your work today?
It's always been about the constant process of learning and understanding. The electrical grid is something, honestly, that has not had any change for almost 50 years. The last time there was a major change in the electrical grid was when nuclear power came on
Mhm.
in the 70s. But since then, we've had almost 50 years of almost no changes. And really, only in the last 5 to 10 years are we things like electric vehicles, photovoltaic, wind, a lot of these things that have really been changed here. And it's an industry that, if you think about it, almost no other industry spent 50 years without any change. So
Mhm.
they are having struggles adapting to those changes. And so, how do you get human behavior to adjust to the way we used to do it is a way we can't do
Okay, and like the side question about the energy
it?
infrastructure, is that a global problem that that it wasn't innovated for 50 years? Because I have my own perspective that in Poland we have like a rather old energy infrastructure. In that way, when we had some kind of a like a solar boom, solar panels boom,
Mhm.
that everyone would like to set it up, then some people were declined to set it up because there is like too much solar panels nearby, and there is like a too many high voltage in the
Mhm.
grid because
Mhm.
the infrastructure cannot take that many prosuments in the area. And so is that like a global problem, or maybe because I've had some kind of a it's kind of a new thing to me because I thought that it is only our problem in our country.
Right. So no, that is an issue that all countries have to deal with, all electrical grids have to deal with.
Hmm.
The unique thing about electricity is any other product you can produce an extra amounts and basically have it in storage and deliver it when it's needed.
Hmm.
And the problem that electricity has is the supply and demand have to be exactly balanced. If you have too much energy, you can overload things. If you don't have enough energy, it'll shut things down. The difference has happened in the last couple of years is now batteries have allowed you to store energy.
Hmm.
And once the batteries became economically and uh, incentivized enough, we can start putting in batteries that, okay, now when you have photovoltaics out there producing too much energy, you can store it in the battery and in the evening or in a different day, deliver the energy. That is really what's changed. And when you talk about technology adoption, in my opinion, there's three things that have to happen. One, it has to be economically viable. So when solar panels and batteries become cheap enough to utilize, now it can be adopted. Second, you have to have a government that wants to support that. They have to
Hmm.
say, okay, we're going to put incentives to make those be adopted. And third, the public wants to make that change. Um, there's probably an issue with the older generation of people say, we have an old system set up. Why make changes to it? And now you have younger generations that say, I want to make things that are safer for the planet, global warming, those type of issues. So
Hmm.
if you have the technology being economical, the government and the people want to have it. When those three things happen, new technology can be adopted.
Okay. And um, well, I've just jumped out of the start from the straight to the point, I would
Yeah.
say,
Yeah.
and about that. And is the change in this infrastructure need to happen now, or maybe we have some time left to do that?
There's a lot of things that are changing that it's hard to say. We put timelines of what has to happen in 2035 or 2050.
Hmm.
Those are typically targets that we try to aim, but we don't know if we could necessarily make it at that point. One of the issues that, say, Europe has that maybe the United States does not have is Europe has an issue with Germany may produce too much energy, Denmark may produce too much energy, or Poland, and trading energy between countries is
Hmm.
a more difficult issue. In the United States, if one state produces extra energy or not enough energy, that energy is traded very easily in the
Hmm.
United States. So the United States has a better handle on trading of energy, but on the renewable solar and wind, we're not as advanced in it. So we can all learn from each other on how to do that. So one of
Hmm.
the issues that kind of, as an American, I look at things like, wow, is interesting. Like Denmark produces more energy than it consumes, so it exports it to Germany. But if they don't deliver what they promise, they pay a penalty. And if they
Hmm.
accept the energy, they also have to pay. So there's these things that are barriers between countries that I think the EU is trying to remove them. So,
Hmm.
if they look to what the United States may be doing, but on the same thing, the United States can see, look how much solar is in Spain and in Germany, and we can adopt those things. So we can ultimately learn from each other about what's the best thing to do because we all have the same problem. We just are going about it a different way.
Hmm. And about that, 2050 as a year has come into the discussion. And from your perspective, because the Europe wanted to make the change by 2050, we even have a one political party which has this year in its name, and it's derived in that change. But my question is, from your perspective, of course, um is that time, is it right, realistic to make a significant change? And or maybe it's like it's maybe or maybe in a different way, it's something like a marketing stunt. We have to put it somewhere in the future. Maybe we'll try to get to that, maybe we don't. And
Yeah.
how's your perspective about that?
Yeah, it's always a bit of an unknown because I would say 15 years ago, did we know that we'd want to have a smartphone and have to do everything with that? It was something that in maybe the year 2005, we had no idea that that was that critical.
Mm-hmm.
And then there's plenty of new technology that's put out there that never becomes that accepted. Let's like say, I mean, a famous example is like the Segway that was supposed to be change the world, and really did it make that much of a difference? No, it didn't. So
Mm-hmm.
I think it becomes when when humans decide they want to go forward and embrace that, it can certainly happen. But we have some technology issues in that if we're going to go completely to electronic vehicles and solar and wind, we have things like critical minerals like lithium, cobalt, nickel that have to be mined and put into the system. Truly, right now, copper's another one that
Mm-hmm.
we almost have to go 5 or 6 times more of those materials that we are currently producing today. And there's always that cost benefit of every time. If you can't grow it, you have to mine it. That's the
Mm-hmm.
that. So if you either grow either wood or food, that's one method. Otherwise, you have to mine it out of the ground. And what's changed in this world today is 100 years ago, you put a dam up or something like that, and there's really no feedback from the public. Now, when you
Mm-hmm.
start making changes like let's put in a bunch of windmills, feedback, people say they don't like that. If you're going to mine, how is it going to affect the culture, the biology in that local area? So there's a lot of things that are moving parts in here that where it's not as simple as, let's say we decide to put railroads and you just put railroads lines in around the country and then it's all set. It is a
Mm-hmm.
lot of changes that have to happen, and it's too early to tell, but it seems as though everybody is embracing about going that. But whenever you make a change like this, there's going to be, it's not all positive. There's going to be some negative impacts to it, whether it's people that make a living off of the old way things are being done,
Mm-hmm.
or the cost to put in the new technology may cost more. Uh, for an EV may cost more money. Using a biofuel for aviation to fly, that may cost a change. So it's hard to say, but my feeling is when things are adopted, nobody wants to be the first thing to do something, but nobody wants to be the last. So as
Mm-hmm.
a whole group of people move together, there's kind of a momentum that everybody embraces.
Mm-hmm. And we've mentioned that we, as a society, and probably also the experts in the energy field, we weren't aware like 20 years ago that the technology revolution, like smartphones or tablets, will be a thing. And so, my question is whether we are trying to have some kind of a forecast what will happen in technology in the coming years. For example, when some like new devices will come out that will consume more energy. Well, probably there is some research on that.
Mhm, mhm. Yes. So what I think the best comparison to make is let's think about aviation
Mm-hmm.
in about 1905, 1904, depending upon if you think it's the Wright brothers or in I think there was another couple of people in France and in Brazil that kind of started aviation at about the same period. Who knew that 50 years later commercial flying between continents was possible and regularly used?
Mm-hmm.
So there is that transformation of about 50 years. I will say that we're in that same way for renewable energy, but we don't know how, if it's going to take 50 years or 25 years or 75 years. And we don't know how far we're in that process. But when you look back at aviation
Mm-hmm.
after World War II, you say, oh, it was very apparent how it went. But I would say probably like in the 1920s and 1930s, we weren't certain that that was going to be a common path, right? So it's so hard to forecast in the future when you're in the middle of a transition. But when it's all done, you look back and say it was obvious, but it was not obvious when it was occurring.
Okay. Um, and how do you see the role of decentralized systems like microgrids in building energy resilience, especially after natural disasters, and maybe what microgrids is in general before we take a look on this question.
Sure. So when the electrical grid was made about 125 years ago,
Mm-hmm.
the only way to make it was you produce energy in a place far away from a population, and then you used power lines to deliver the high voltage back to where it's being consumed.
Mm-hmm.
Microgrids, or locally making the energy in small amounts and delivering it close to where it's being used, was not economically feasible. If you're going to start and make an electrical grid brand new today, you wouldn't do it the way it was done 100 years ago, because it's more economically to put in, whether it's solar or hydropower locally, and deliver it as you need, and you can store energy with batteries. That's how you're going to build it. And think of a microgrid kind of like you might think of the continent of Europe, that
Mm-hmm.
Germany's doing their own thing, France is doing their own thing. Each country is kind of producing their own energy, and as the continent is connecting together, and so is the name of the group that starts talking about, hey, can we deliver energy from Ireland to Great Britain, Ireland to France, France to Germany? Those type of things are starting to trade back and forth. And think
Mm-hmm.
of a microgrid as, then take each country and start making that energy available in the small areas of a region in the country. And the idea is, if you have a natural disaster, whether it's a flood or severe storms, instead of a severe weather knocking down a high voltage line that will knock out power for tens of thousands or hundreds of thousands, now with microgrids, you may only knock out an area that's maybe several hundred people. So you have the ability to, one, route energy around a natural disaster, but two, the impact of something happening is less impactful. When I was involved in Puerto Rico,
Mm-hmm.
if we would get a couple centimeters of rain, power would go out, and it would cause it to go out in the entire island. If
Mm-hmm.
you make the island into a bunch of microgrids, think of it like puzzle pieces in a puzzle. If one puzzle piece is missing, that doesn't affect the entire island. But if the island is one puzzle piece, if it goes bad, it affects everybody. So what we're trying to do is minimize how things are affected locally, and that's the way that we're making that change. But the one thing that's difficult about the electrical grid is, you can't make those changes and shut it down.
Mm-hmm.
So it's like remodeling a house, but the electricity still has to work, the plumbing has to work. That makes things more difficult. That if we close a highway and rebuild it, it can happen much quicker. But if you're remodeling a highway, but people still have to drive on it, it takes longer. It's more difficult. It's more complex, right? So these issues are, I wouldn't say harder, they're just more complex, because how do you do that but yet keep the current system?
Mm-hmm. So the crucial benefit of that is then we can avoid the blackouts.
Yes.
Mm-hmm.
Yes. And that's one of the issues that we really avoid, is if you have a big enough blackout, restarting it is far more difficult than if you keep the blackout into a small contained area, work around it, repair that. And that's ultimately what you want to do.
Mm-hmm. And so, can renewable energy transition can it truly be global, or will it be always remain some kind of a privilege of developed countries?
Yeah, that is something that I've spent a lot of time on. In that, yes, it is a common problem, but how you address that, we have to look at it, because things like we talked about, some of those rare minerals like
Mm-hmm.
lithium, becomes very expensive to buy those type of batteries. There are other batteries and technologies out there. One is called an iron redox battery, but basically it's made out of iron, the fourth most common element in the world. And really, one of the ideas is, if you make a big battery, where essentially how it works is, when iron rusts, it produces electrons. So if you create what's called a rust battery, you can put it in a developing country, very economical to implement. but you can't put that type of a battery on a car because it's not as dense. So it's a big thing. But if you're trying to power a local community, you can have a big battery of tractors, like truck tractors that are set up and stacked up that you can make that kind of battery very, very cheaply,
Mm-hmm.
but it doesn't work necessarily for a car.
Mm-hmm.
But there are technologies that we have to look at. How do we have some economic justice for developing countries to embrace this? Because the last thing I think we want to do is, okay, the well-off countries make this transition, make this benefit, and the developing countries fall further behind because they are impaired with, we only have fossil fuels to do things, and leave people behind. So that is a concern that we have to make sure we look at.
Mm-hmm. And before we proceed, I'll maybe ask a question about like our local thing, because in Poland we have some kind of mm, maybe a bit of a problem because our energy system is still mainly residing on the coal.
Yeah.
And probably I was driving from Warsaw to Novi Sad yesterday, and I've had the climate announcement around 8 p.m. that the renewable energy is only 25 or 30% of our network during that moment. And how difficult is it for our countries? And I consider Poland as a pretty developed country to transfer from the coal-based energy system when we also have a problem that our coal infrastructure and mines are pretty expensive to operate, because our government, for example, is still given the money in order to keep the mines operating.
Mhm.
And still it's kind of difficult to do that. For example, I've heard that one of the energy companies trying to make local small modular reactors, which will be placed near the Baltic Sea. But I still think that it's like it's a step one when the steps are like 10 or 20 to be done, and how difficult it is to transform the energy system, which is coal based, like in Poland.
Yes, I can speak that in the United States, coal was the majority that was used to produce energy, and now it is natural gas.
Mm-hmm.
I see this. I think you were very correct that this is. I think we as humans tend to think things as a yes or no, a
Mm-hmm.
one option, and it's more of a gray transition. So it doesn't go from coal to renewable energy right away. It's coal, then maybe natural gas, because I would say that's the cleaner fossil fuel, and then you transition towards more solar, more wind, more. There's been some thoughts of you use smaller rivers instead of having a very, very big dam. Do you just put things in like the old type of water wheels that could use and power things? So how do you make transitions slowly, slowly, slowly from one technology to the next? So we tend to think of these as we turn on a switch and it changes from this to this, but it's usually a very multi-step process that we have to think about. We make changes here that, hey, you're only at 20 or 30% renewable power, but I bet you 5 years ago it may have been half that. So we
Mm-hmm.
tend to think of things right in the moment and not going back to that aviation analysis. We're in the midst of this transition. We just don't know how far we are or how fast it's going. And then when you get a little bit more perspective 3-4 years from now, and you say, wow, we were uncertain about this. And that's part of what I think the engineers and scientists have to do a better job in communicating is, okay, if we're getting rid of coal, how does that affect people that are employed by coal mines?
Mm-hmm.
How do you whether it's retrain or readopt people that are doing that? And some of that ends up being kind of a generational thing, in that people that have been working for years in those jobs worry about losing their jobs. The younger generation coming up are excited about getting away from coal, but they don't see how it affects people living in there. So how do you manage the expectations of, yes, we're making this change, but ultimately it's a good thing? How do we make sure that those people are protected as you
Mhm.
go in there? But let's not all of a sudden make energy so expensive that now people can't pay for food because their energy is so expensive. And so we have to, it's a delicate balance to do that. But every time we make a technology change, people are affected. When we went from horse-drawn carriages
Mhm.
to gasoline and petrol-powered vehicles to now maybe electronic vehicles, there's been that constant change. And how do we say it will be okay, but make sure that people are taken care of? And that's, I mean, that's it's always a balance, right?
Mhm. Okay. Okay, so maybe let's take another topic as well, because I think we can also speak something about the innovation and technology in the energy infrastructure, because I have a bit of an IT field
Mm.
from this university to. So I would say a question that will go like this: how do you see AI and machine learning shaping the future of energy systems? How crucial it is nowadays.
Yes, it's what I'd say it's a what we call a double-edged sword
Hmm.
that, AI or AI searches and usage has about 10 times the energy of a Google prompt search. It
Hmm.
costs a lot more energy to do deeper thinking with AI. At the same time, when I started talking about microgrids, AI has the ability to move energy around
Hmm.
between one microgrid and another, that we can be more efficient on how we use energy. Um, as we are transforming, one of the issues and sorry, I'm jumping a little bit here, but
Hmm.
one of the things why we're not using as much energy as we used to is that appliances, things are becoming more and more efficient. And what I see is the AI can be part of the issue, but ultimately the solution, that AI will have the ability to better utilize the energy to be more efficient, so that, yes, we are technically using more energy, but we're using it more efficiently. So I think ultimately, once we get through this kind of learning process,
Hmm.
AI will be a valuable tool for energy efficiency.
Yeah, because I've asked this question because I've had some paradox, because we are utilizing artificial intelligence in order to make our processes in general better,
Yeah.
but also the AI is raising. I mean, the AI servers and all things regarding that are raising my personal concern of that that the servers and the places when the servers are located are ridiculously ridiculously overpowered. I mean, they consume a lot of energy to do that. And for example, I think I can call the company by itself. When Elon Musk took the Twitter and recalled it to X, there was some kind of a controversy that he had launched the XAI, which was like located. The servers were located in some place that it consumed a ridiculous amount of energy, and it wasn't that. It wasn't based much on the clean energy, I would say. So that's why I asked that, because I have a bit of a concern that we are using AI a little bit too much, especially when there's some reports, for example, in Poland, that too many people of my generation are using, for example, ChatGPT as a replace for meeting another person. So
Mhm.
I think we are wasting tokens and so the energy on something that we could use another person.
Yes. I mean, one of the things I think we can look at too is with the data centers and AI, we can start using things for what we call cogeneration. So the heat that's being produced by those data centers, can that heat be transferred into general heating of cities and public buildings, things like that? So we are utilizing that energy better. And the AI has the ability, we talked about, that you can start forecasting that if you see a storm coming from another part of the region, you can shift the energy from producing energy from solar in the area where the storm is coming,
Hmm.
that you can target for energy after the storm has passed, and you have the ability to, like we say, circulate energy around things like weather patterns, things like that. But you're right that once we going back to using AI for mundane things that aren't necessary, I think people will get smarter. Maybe after the novelty of using it every day, maybe you don't necessarily have to use it. And I use it for some things, but typically not the easy things. If I want to do something, I'd be more strategic in how I use that, and whether that becomes a cost thing where you start saying, hey, if you want to use it, it costs so much. So then you are smarter when you use it for things. I don't know, but you're right that for right now, because it's still very novel, everybody is excited to try and use it. And we
Hmm.
need to teach people that there is a cost for doing that. And right now, the average person doesn't see the costs for them, right? Because they just, if
Hmm.
it's available on their phone, they use it, but they don't see that it causes energy being consumed at some server, kilometers away. We have to, again, going back to the human behavior, we have to talk to people that every time you do something that causes a change amongst that, if become, I think people are, if they're made aware, they want to do the right thing. So we
Hmm.
need to help people understand.
Okay. And we have to speed up a bit
Mm,
of my next topics because we have some next events that are coming up.
sure.
So, like a quick question: which global regions do you think are the most promising for innovation in the clean energy today, and why?
Yes, I mean Europe has been one of the better areas for solar and wind installations. China is obviously one of the most important because they are so heavily, they control around 80% of all battery materials refining and manufacturing. Same thing with solar panels. So they are very important in it. I think the United States has become less involved in that, unfortunately, from the innovation part of it. But I would say that the United States, from the microgrid, is one of the leading areas of the world in there. So again, we talk about it doing the best practices of what Europe does, what the United States has done, what developing countries need to learn to come up to speed and adopt it. The one problem with energy is it's not like um, consumers that may use Amazon or other global retail companies that learn from each other. What's done in France and what's done in Australia, there's not much talking about, oh, they're doing this or doing that
Hmm.
there, versus what's done in a smartphone in one country becomes easily done in a smartphone in another country. We have to be better at communicating those things. And so when I travel globally and say, hey, this is being done, oh, we should look at that. So better communication for what's being done globally in trading of information is going to make everybody better.
Okay. And the last question: what advice would you give to young engineers or students who want to enter the renewable energy sector, considering that the students from WSB-NLU will be watching us?
Yes. I think it's the most exciting part that energy has ever been at. And the interesting thing is that there are newer perspectives. A typical person involved in the energy sector was an electrical engineer. Now things like batteries and solar panels, those are more material science and chemical engineering. AI, so now you've got things like computer science, but you've also got cybersecurity. There's a lot of areas that are very, very involved that honestly, just because you transition to renewable energy, things like cyber protection becomes a very, very big thing that it's creating a lot of opportunities in that sector.
Hmm.
And the good thing about the energy sector is it's always going to be local. It's not. I mean, you may make this solar panel in a different country, but you're actually producing energy and utilizing it locally within the country you're at. So I think that always is going to provide security for local jobs and careers.
Okay. Robert Peterson, thank you so much for joining us today on our WSB-NLU po godzinach talk. Thank you so much. Dziękuję Państwu bardzo za to, że obejrzeli Państwo ten odcinek, że obejrzeliście w zasadzie. Rozmowa była na tyle poważna, że aż mi się przedstawiły, w jaki sposób ja mam się zwracać do ludzi. To było wszystko. Naszym gościem dzisiaj był Robert Peterson. Można powiedzieć, że ekspert do spraw energetyki i wszystkiego, co się dzieje, jeśli chodzi o jak działa energetyka w obliczu chociażby zmian klimatu. I o tym wszystkim porozmawialiśmy dzisiaj właśnie w podcaście WSB-NLU po godzinach. Maksymilian Motyka, bardzo, bardzo Wam dziękuję. Program zrealizowali dla Was Krzysztof Pazgan i Paweł Augustyn, a wydawali Amadeusz Rejentowicz, Jolanta Witowska, Michał Kapała. Ja nazywam się Maksymilian Motyka. Dziękuję Wam bardzo za oglądanie i za słuchanie i do zobaczenia w kolejnym odcinku.